And now we will implement an activation function in Cuda, which is the ReLU function. Before we start, make sure that you hit that like button and subscribe to my channel. Also, the code for this problem and other solutions for Cuda programming language is in the description. You can follow with that as well. And let's get into the problem. What we want to do is we want to perform a ReLU activation on an input matrix, which is A, I, and J. And the output of this ReLU function will be basically the maximum of 0 and the input, which can be defined as this. If our x, which is our input, which is aij, is greater than 0, we will return x. Otherwise, if it is 0 or less than 0, we will return 0. The thing here is that the input is a matrix with size m to n, and output is also a matrix m to n. And both matrices are stored in row major order, and we will actually use this. This is actually the default one, okay, but we will be accessing the elements of the matrices by knowing this information. So the first thing that is different from the other problems we have done so far is that the input and outputs are matrices. So we have to, with threads, access two elements. And for that, we will do something different. That is, our threads per block will be in terms of dimension 3. And we will make it 16 to 16. And we will calculate blocks by grid using this formula. Again, I won't explain why this works, but it will just make sure that there are enough threads for nxm times data points. After that, we will call our function ReLU, and the same thing, we will pass blocks per grid and threads per block. Inputs will be input, output, n and m, and we will do Cuda device synchronize. So for the three-dimensional problems, this is the default thing that we do in Cuda. Now let's start defining our function, which is we start by global and we use the type void. Name is ReLU in this case because we are calculating the ReLU activation. Input is constant float input, which is a matrix. Output is not constant because we will write the information into this. And the dimensions of the matrices, which are constant, n and m. Instead of having one unique element, we will have two unique elements compared to a vector. We will have a unique element for row, which we will calculate by block index.y multiplied by block dimension y and thread index y. And for the column, the same formula, just x instead of y. So this will give us a unique row and column ID. And by this, we will be actually able to traverse a matrix in the Cuda using threads. We traverse through every row and every column. And of course, if row is greater than equals to n or column is greater than equal to m, which means that we are out of bounds and we return. And we don't continue to execute the function. Up to now, these were the basic Cuda building blocks for working with matrices. Now we will go to the actual solution, which is very simple. We will just check this element. X will be our input row and column. And if it is greater than 0, we will return x. Else, if it is less than 0, we will return 0. But we cannot access it like input bracket row, close bracket, open bracket column, and cross bracket column. In Cuda, we have to access it by thinking that it is a 1D vector. Because in Cuda, it is actually, the memory is in 1D. So we cannot do like input, row, column. We cannot do that, but we know one information. And of course, by default, it is in row major order. And how we access row and column is that we take the row multiplied by m and add the column. So if our input element is greater than 0, which means that we are in here, we will return X, which means that we'll go to output and we will go to the row and column element and we will make it exactly equal to X. Else, it has to be less than 0, and in that case, we will just make it equal to 0 and close the brackets, and that's all. Let's run this code. We got a compiled error because I forgot this in here. Let's run it again. And it has passed. Now let's submit this. And our solution has been accepted, and these are the stats. So this is how we implement the ReLU activation in Cuda and solve this problem. The GitHub of the code is in the description, as well as solution to the other problems. And see you at another problem.